And so we're going to look at one more technique for integration using Maple. And this one is going to be, what about if we have one of those terrible partial fraction decomposition problems? How can we get Maple to not only give us the integration, but maybe show us a little bit about the middle steps and how that came about? Okay, and so, I don't know, let's first pick a rational function to work with. I always like number 37, so let's do that. So this looks like x squared minus 3x plus 7. I'm going to highlight this so that when I hit the divide button, everything is in the numerator. And then in my denominator, whoops, I copied everything into my exponent there. Let's see. So I hit 2 in my exponent. Now I'm going to hit over, and that'll push me back down into the base. There. And then this thing was squared. Okay, and I hit enter, and there's my rational function. I can suppress that so I don't have to look at it. And so the next thing we want to do is the following. We want to type in convert, and I want to convert that thing that I just named using what? Using partial fractions. Okay? And there you have it. So what has this done for us? This has taken this overall term, and it's used synthetic division to break it into this term here, or I'm sorry, not synthetic division, rather just the partial fraction decomposition. This was a proper fraction to begin with, so there was no improper fraction step. So you would have written this as a over this thing, and then plus bx plus c over this thing squared, because the whole denominator is squared. Okay. Now the one thing that this is not doing for us is showing that this could be written as an irreducible quadratic, we call that. So to get that effect, we could do the following. We could say, oh, I don't know, that we want x to be replaced with u plus 2. In fact, let's look at u plus 2. X is equal to u plus 2 inside of my rat function first, and this maybe will help you show you why I'm picking the way I am. Not quite yet. Okay, so what I did is, the reason I picked u plus 2 is because I knew that if u is equal, if x is equal to u plus 2, that means that u is equal to x minus 2. And having completed the square in this problem in the past, I know that that's exactly what will complete this square, and it'll reduce x squared minus 4x plus 6 down to an irreducible quadratic form, where I can see u is just squared, and it's u squared plus a squared. A squared happens to be 2 in this case. Okay, so let's say that this now is my second rational function. Okay, and maybe I want to convert that now. Whoops, I should have named that something else. Let's say just 2 there. Okay, and so I want to convert the second expression using partial fractions. Okay, and this is a little bit more like what we're used to seeing. Okay, so this is my irreducible quadratic term, and in general I could have a constant times u plus another constant, and here I've got a constant times u plus another constant over the denominator squared, okay, which comes from looking at the form of the original partial fraction. Okay, now finally the last thing I can do is let's give this a name. let's just say P frac. Okay, I can integrate the rational function with respect to x. And let's say that that is my rational integral. And then I can integrate my partial fraction decomposition. And this will take a few different steps because of my u substitution that I'm making, so let's go slowly. I'm going to take p int. This is what happens when I integrate my partial fraction decomposition with respect to u. Okay. And let's get the value of the rational integral first. And there it is in all its hideous glory, the answer to number 37. Okay, and then I've got p int. Let's get the value of that integral. Okay, and it looks a little bit simpler, but notice how things are going to line up. This 1/8 with a rational function showing up is going to is going to simplify to this part, and the 7/8 square root of 2 arctan is exactly this part. In order to see that, let's make one last step. We're going to undo our substitution we made. So instead of writing x equal to u plus 2, I'm going to write u equal to x minus 2. That will undo my substitution and write everything in terms of x. And as you can see, aside from just having reversed the order of the two terms it's adding, it's exactly the same expression. Okay? And so that's how we can do partial fraction decomposition and just sort of get a glance at the middle hideous steps as we go.